Hello, everybody. This is Dr. Marjan Assefi. We have so many types of microscopies. We have compound microscopy, fluorescence microscopy, electron microscopy, even confocal, scanning electron, or a scanning tunnel, atomic force microscopy. But today we are going to talk about light microscopy. As you know, light microscopy is used to make small structures and samples visible by providing a magnified image, for example, magnified of 400, 100, 440 image of how they interact with visible light, their absorption, reflection, and also their scattering. And this is useful because it is useful to understand what the sample looks like and what is it made of, but also allow us to see processes of the microscopy's work, such as how substances diffuse across a cell membrane. So this is really important. There is some guidelines for using the light microscopy. Always carry with 2 hands, as you know, only use lens paper for cleaning. Do not force knobs on, always store covered. So these are the essential ones that you should be careful about that. This is a part of microscopy parts, body tube, eyepiece, and revolving, and also objective lens. So we are going to talk about those objective lens and eyepiece lens. Objective lens that collect as much light from the sample as possible, but in the eyepiece lens, which relays the collected light to the observer's eyes or a camera system. So this is really important. The image system may also include elements such as the filters that they use, and they select a certain portion of the light from the sample, for example, to see only light that has been scattered of the sample, or only light of a certain color or wavelength. So this is important. But the illumination and the imaging system play a key role in how well a light microscopy performs. To get the best result out of it in your application, it is essential to have a good understanding of how a basic light microscopy works and what variation exists today. And as you know, a single lens can be used as a magnifying glass, which increases the apparent size of an object when it is held close to the lens. Looking through the magnifying glasses at the object, we see magnified and virtual image of the object. And this type of the microscopy can achieve a magnification of typically even 100, 400, and also 40 magnifier, which is sufficient to study relatively large samples. However, achieving higher magnification and better image quality required the use of more optical elements, which led to the development and compound microscopy, which in next weeks we are going to talk about them later. In the compound microscopy, the sample is illuminated from the bottom to observe transmitted light, or from the top to observe reflected light. So the light in the compound microscopy, light from the sample is collected by an optical system. So as you know, it's consisting of 2 main lens groups, the objective and eyepiece, whose individual power multiplied to enable much higher, even much higher magnifications than those achieved by a small microscopy. And in a focusing one, always start with the scanning objects. You will be able to see something on this setting as you see here. And also you should be careful about the bright field microscopy, which is the simplest form of the light microscopy, where the sample is illuminated from above or below, and the light transmitted through or reflected from it is collected to form an image that can be viewed. So these are the most essential part of it. And also dark field microscopy, you should consider that is a technique that only light that is scattered by sample is collected. This is achieved by adding that blocks the illumination light from the being imaged directly. So these are the essential part of it, and your slide must be focused on the low air power before the attempting this step, and click the nose piece to the longest objective, and do not use the coarse focusing knob. This could crack the slide or the lens, and also use the fine focus knob to bring the slide. So this is the image is a kind of light microscopy, as you see here, and as we discuss part or different kind of light microscopy that we talked about them today. So I hope you will enjoy our next microscopies that I'm going to talk about. So for next one, I'm going to talk about transmission electron microscopy or TEM microscopy.